Uh, Hello everyone, good afternoon. Today we'll be talking about the topic Big Billion Scale. This is about serving billion of Indians the shopping experience they get and about scaling high performance platforms at Flipkart to support that. To briefly touch upon this talk's agenda, uh, we'll be starting with Flipkart's journey with Aerospike and how has it evolved on Kubernetes in last few years, and how has Aerospike Kubernetes Operator has helped us in achieving that, along with some scale, some challenges that we have faced, some optimizations that we have built, and how this Aerospike is being provided as a service inside Flipkart. To start with the Flipkart's journey, this is where we are right now. We are serving more than 50 use cases with Aerospike, and a peak performance of by one cluster we are able to achieve up to 10 million. The combined QPS on all of our clusters on Aerospike inside Flipkart across 3 data centers is 90 million, and all of this is being achieved with a team size of less than 10 developers. To discuss a little brief about the use cases that we have, we serve both cache as well as source of truth systems using Aerospike. And the search bar that you see on the Flipkart application, this is also being powered by Aerospike along with some other components. Apart from this, we use Aerospike for browse pages, feature store, recommendations, ads, inventory, pricing, offers, and many more other use cases. To give you a little bit history, we have been using, these teams have been using Aerospike as their own self-managed Aerospike cluster. By self-managed, I mean they were creating their own Aerospike cluster and solving all the challenges that were coming up with those clusters. So just to talk about the challenges that may arise if you are managing your own Aerospike cluster is with infrastructure management, where these clusters are created on virtual machines and it is hard to get the perfect cut of the virtual machines that you want to create. Ultimately, either those clusters may end up with over-provisioning or some other resources may get bottlenecked. Some other challenges like scaling, where individual team had to develop that expertise to figure out those scaling related challenges and what should be done in order to address them. Some other things like alerting, monitoring, disaster recovery had to be developed within each and every team. That's where the foundation of Aerospike Database-as-a-Service began. This team was created with certain objectives and motivations in mind. We wanted to have subject matter expertise inside Flipkart so that if there are any issues, this team can be referred to address them. We wanted to make sure that all the cluster management are easy and to improve developer productivity where the actual application team can focus on the business use cases rather than the Aerospike database related challenges. We wanted to address a centralized disaster recovery, and version certification and upgrades should be easy. We wanted to make sure that all the clusters that are running inside Flipkart should have a version consistency, and also all the version upgrades are tested upfront, and this system should be resilient. That's where we entered Kubernetes. There were multiple approaches evaluated, and Kubernetes was a winner. So it promotes infrastructure as a code. It provides flexibility in pod shapes, so the virtual machine related challenges are automatically addressed where we can create any pod shape that we want. It provides quick and easy scaling of clusters, specifically horizontal scaling. And it provides some of the best practices are naturally addressed where we do not have to SSH into the virtual machines to make some configuration changes or access them, and we can do it outside. To discuss a little bit deeper about the Kubernetes deployment strategy that we have divided the overall deployments into two parts, control plane and data plane. The control plane consists of Aerospike Kubernetes Operator, which connects with API server, and we have monitoring setup, which consists of Prometheus and Grafana. And there is an application, management plane application, which continuously monitors the Prometheus metrics and takes certain decisions through AKO. The other part is the data plane, where we have Aerospike clusters hosted. These Aerospike clusters are created using AKO, and these are on Kubernetes. These clusters are hosted on node, and one node may contain multiple pods of any Aerospike cluster. So that's how we use multi-pod per host to true. And we also have load balancer in front of Aerospike cluster, so that if there are any membership changes are there, the application is automatically handled. To talk a little more about the data plane side of it, we create multiple Kubernetes namespaces. These namespaces are created for a specific purpose. The Kubernetes operator, there is a management namespace which handles the Kubernetes operator, Grafana, Prometheus, etc. And we create multiple workload namespaces. These workload namespaces help us utilize the heterogeneous infrastructure that is available to us. And we are able to utilize the low performant older generation of hardware for low critical kind of use cases, and create a separate namespace for high critical use cases where we need higher performance from the generation of hardware. We also create different namespaces, Kubernetes namespaces for type of workloads, where we want to separate them out for in-memory versus hybrid use cases. To achieving all of it, the AKO, Aerospike Kubernetes Operator, has helped us with respect to the deployment. We need to create a manifest file. The manifest file consists of number of pods, the pod configuration like memory, disk, CPUs, and some Aerospike related configuration, namespace, high watermark, etc. And we can use that manifest file to make those deployments. It gives us version management, where configurations and version management, where we can just change the version of Aerospike cluster in the manifest, and it would automatically, the deployment part would be taken care by AKO. It provides us seamless horizontal and vertical scaling. Horizontal scaling is fine, but the vertical scaling, which is not out of the box supported by Kubernetes, the AKO takes care of it seamlessly, where it creates another similar deployment and moves all of our workloads to the newer one. Other commonly used features of AKO are pause, dynamic restart, maintenance. These are some of the features which we use very extensively. So all of this journey and how we deploy a cluster, this everything is just maintained as a code. So here a user will come onto our management plane, and it will give us some of the non-functional and functional requirements. Based on this, this application will convert it into a configuration file, which is then put on GitHub. The CI/CD will pick up the configuration file and merge it with Helm to create the manifest file, which is picked up by operator and then seamlessly converted into an Aerospike cluster. In this whole journey, the code or the actual virtual machines are never touched. We internally support two kind of topologies, in-memory and hybrid. And this topology selection is based on certain non-functional requirements like scale, consistency, data size, and persistence. This in-memory workload we choose for serving low latency, high throughput kind of use cases, because there is no disk involved in it, and specifically the IOPS related bottlenecks are not there. And we choose hybrid for moderate throughput kind of use cases and also expects durability. Okay, to talk about certain challenges with scale, these are certain complex challenges that we have faced with Aerospike, which is hotspotting, scaling the secondary index queries, and identifying correct configuration with single key versus batch key use cases. For them, we For hotspotting specifically, we try to solve it with provisioning of high replication factor and redistributing the reads, and other configuration we solve it by changing thread configurations proactively. There are certain infrastructure related challenges as well, since this is deployed on Kubernetes and a node may contain multiple pods. It will result into noisy neighbor in case one node contains a lot of pods which are high QPS. To solve it, we try to proactively identify high performant pods or high performant Aerospike clusters and distribute them evenly, and we also try to make sure that as much as resource isolation we can get on those pod specific resources, that is we try to aim. Apart from this, we also proactively identify node and hardware issues to keep the Aerospike clusters up and running. That is about the infrastructure. We have created an ecosystem around Aerospike to handle large number of requirements, and I'll call Sahil present.
Yeah. Hello, mic testing. Am I audible?
Yeah.
Sure. Thanks, Aditya, for concluding our Kubernetes journey and the deployment model. So I will be covering the DBaaS ecosystem. It's not just about Aerospike, it's about the ecosystem or the components that we have built. Before that, I just wanted to talk about the scale also. So you must have seen the 10 million QPS. So if you have referred the earlier slide, it's around like the phone pays per minute. Phone pay per day QPS was 36 crore. We overtake it per minute. And for the Airtel, we do 100x of. So now you know what the real scale is. So talking about the challenges, so we face various challenges and we have built various components out of it. So first being cluster management request, we have more than 200 plus clusters running on our AKO, Aerospike Kubernetes Operator, and the scale, the problems like the capacity request, the onboardings, it's very hard to maintain each of them. Other problem was, as we have too many clusters, we need to optimize the overall hardware usage. We need to make sure the over provision cluster is settled with the under provision, and overall the usage is less and we can deliver more throughput with less time. Also, debugging was a concern. So you must be knowing that like Aerospike would be deployed on some server, maybe VM or Kubernetes. So we need to monitor both the Aerospike server. Is this bottlenecking on an Aerospike server? Is it bottlenecking on Kubernetes? So we just created one unified dashboard. We'll talk about that. Also on the disaster recovery strategy, so like you must be knowing the cross data replication and the AS backup and restore. So like which is better and at which time. So we have also done extensive benchmarking for this. And at last, the optimal hardware estimates. Talking about the DBaaS web portal, this is a user interface that we have created for all our tenants. By tenant, I mean the Flipkart internal teams that use Aerospike. So they can just register their use case, mention all the NFR requirements, the latency, the read QPS, write QPS, the Aerospike configuration, all that seamlessly, and we will make sure that this appropriate cluster hardware is provided. They can also track their year-on-year progression of how many deployments happened and what will be the scale, next scale. So using this data, we come to a calculation. This is something that we have worked hard from last 2-3 years and come to it. So this is something that we have built like extensive to Flipkart. How, like if a user registers, what optimal hardware we can provide. Even this is even smart. It has smart intelligence that it can provide the cluster should be hardware or like a cluster should be hybrid or in memory. This it predicts through multiple factors like the throughput or the persistence or the QPS. Apart from the hardware calculator, we also need to test the client configuration, the tend interval, the batch index, that's all these needs to be done. For testing that, what we do is like we run a chaos testing. So as a platform team, the number one priority is our system being stable even when it's in degraded state. So we do a chaos test where user can come and just onboard to us and just kill few pods and test that system is able to come up, the client latency is low, the errors rate are low. So we measure the data loss is not happening, we measure the Kubernetes pods are getting recreated. All this is done seamlessly through this. On the monitoring stack or the observability, we had done extensive work. So we have created a centralized, like customized alerting and centralized logging. When we say about metrics, so how it is powered. So this is a single Aerospike pod. It will have two containers. One is Aerospike server, which runs all the traffic, and one will be Aerospike Prometheus exporter. What it does is like it just export all the metrics to /metrics, and the Prometheus on a pull-based mechanism just pull all the data, and that we used for visualization through Grafana and alerting. And a centralized logging is we just do asynchronously std out our logs to a central store. So this is a unified dashboard that we have created, like the mix of Aerospike and infra. So you can see the infra detail, the pod usage, the memory, namespace usage, bandwidth, all this is calculated, and we just like calculate like if it is breaching some a certain threshold. If the cluster is not scaling, what can be the factor? Is either it is infra or the Aerospike server itself is not able to scale up. So this is used like to help us troubleshoot the requirement. So I was talking about there are two strategies. So we did extensive benchmarking. So we could find out that XDR is better when we are providing better RPO. Even we have a feature to throttle the restore. And backup and restore is better when we need to provide better RTO. And it is also resilient to data corruption. So, for the resource optimization, we had various reports. So, like usage report, fragmentation reports, and the data loss reports, which helps us to identify the key clusters that are over provisioned. We can under provision them. Also, the fragmentation percentage, which we can reduce by defrag LTM percentage. And even in case of pod or data crash, we will just be notified by this data loss report, which will tell us how much is the data impacted. So there are few future enhancements that we are currently working. First is the automated hardware scaling. So the last slide reporting we use as a data metric, and it helps us to using predictive AI we use to us to predict the future hardware size. So it helps us to overall what will be our infrastructure usage. So it helps us to predict the overall usage and how much the infra will be required. Also, in the AI DevOps engineer, it's like a cool AI stuff where, so there is a huge pain in operator upgrade or server upgrade. So what it does is seamlessly do all the operational work, and what we need to do is just visualize it. It is something that is currently in work, yeah. We also have future like planning of having conversational database access and connector support on K8s. Yeah, thank you.